Hi everyone, my name is Janine and I make educational videos like this. If you're interested in seeing more, you know what to do. Please subscribe to the channel, make sure to hit that notification bell, and give me a thumbs up if you like this video. In the previous classes, we've learned so far that factoring and rationalization are two techniques that we can apply to evaluate our limits. So in this class, we will solely focus on rationalization for us to eliminate indeterminate forms and then evaluate our limits. So as I mentioned, if we look at question 1, all we have to do really is apply direct substitution and see whether we're going to result to an indeterminate form before we figure out a technique, which is going to be rationalization. So after applying direct substitution by plugging in 25 into your x, you see that you do get an indeterminate form. As I mentioned, indeterminate forms are problematic, and therefore we're applying rationalization in this particular example to eliminate this indeterminate form. So we would take 5 minus square root of x over 25x minus x squared. So when I say rationalization, we're rationalizing our numerator by multiplying 5 minus square root of x to its conjugate. So it would be 5 plus square root of x over 5 plus square root of x. And in fact, when we look at our numerator, so this is a minus b, and this is a plus b, we see that we do have the formula difference of squares that is being applied, and hence we're able to apply and ultimately rewrite our numerator in terms of a squared minus b squared. So in this case, you would have 25 minus x. And the only reason why our b squared is x is because if you were to square root of x, because our b is square root of x, when you square that, you do get x. Okay, great. So we were able to figure out our numerator, which is 25 minus x. And if we were to consider our denominator, so we do have to multiply 25x minus x squared to 5 plus square root of x. And if you take a look at your numerator, you do have 25 minus x, which we can actually cancel out with our denominator because we do have a greatest common factor of x in our denominator, and specifically we're looking at 25x minus x squared. So if we were to factor out x in our denominator, we get x times 25 minus x, and this is multiplied to 5 plus square root of x. We're able to cancel out 25 minus x, and we're left with 1 over x times 5 plus square root of x. And this is the time you evaluate your limit because you're able to eliminate 25 minus x, which is causing you to result to an indeterminate form. So we take the limit when x approaches 25. So we would use our simplified expression, which is 1 over x times 5 plus square root of x. So we're just applying direct substitution here. So we have 1 over 25 times 5 plus square root of 25. So we do get 1 over 250 as our final answer. And hence our limit when x approaches 25 is 1 over 250 for question 1. Now looking at example 2, we see that we have limit when x approaches -3, and we do have square root of x squared plus 7 minus 4 over x plus 3. So I guess if you were to consider example 1, we do have a radical in our numerator. And if you were to look at number 2, we also have a radical in our numerator. However, there's 2 terms comprising this radical. And really, it's the same concept. You apply direct substitution by plugging in -3 into your x and see whether you do get an indeterminate form. And in this case, yes, you do get an indeterminate form, which is 0 over 0. And that's why we need to rationalize our numerator, which is square root of x squared plus 7 minus 4. So we take our numerator, which is square root of x squared plus 7 minus 4, and this is over x plus 3. And by the way, as a friendly reminder, it's really important for you to make sure you separate -4 from your radical expression, just because I've seen students who tend to forget that. So just a heads up. So you have to multiply this expression, square root of x squared plus 7 minus 4 over x plus 3, to its conjugate. Specifically the conjugate of the numerator, which is square root of x squared plus 7, and this is plus 4. And this is all over square root of x squared plus 7, and this is plus 4. Great, so again, we can apply difference of squares as I mentioned in the previous question. So this is a minus b, this is a plus b. You multiply them together, you get a squared minus b squared. So essentially, we're rewriting our numerator in terms of a squared minus b squared. So in this case, we would have x squared plus 7. So that's a squared minus b squared. So in this case, this would be 16. And this is all over x plus 3 times square root of x squared plus 7 plus 4. Simplifying our numerator, we get x squared minus 9 over x plus 3 times square root of x squared plus 7 plus 4. And as you look at your numerator, x squared minus 9, we can apply the formula for difference of squares, which is x plus 3 times x minus 3. And this is over x plus 3 times square root of x squared plus 7. So we're keeping our denominator the same, and we're ultimately able to cancel out x plus 3 in both our numerator and our denominator. And yeah, pretty much our job here in terms of simplifying is done, because we're able to evaluate the limit when x approaches negative 3 using the modified expression that we have. So limit when x approaches negative 3, we have x minus 3 over square root of x squared plus 7, and this is plus 4. So we apply direct substitution, so we would have negative 3 minus 3 over square root of negative 3 squared plus 7, and this is plus 4. So just take your calculator and just punch in the numbers. So negative 3 minus 3 over square root of negative 3 squared plus 7 plus 4. So our final answer in this case would be negative 3 over 4. And as I mentioned earlier, anytime you're typing in radical expressions in your calculator, just make sure that, like, let's say if you look at this plus 4 over here, make sure not to include it into your radical expression accidentally. So make sure to actually do leave that space by clicking on the right arrow key in your calculator. Because otherwise that changes everything, right? So great, so we can move on to number 3. So we have a limit when h approaches 0, and this is square root of 4 plus h minus 2 all over h. So again, we do have a radical expression in our numerator, so the technique is still going to be similar. So we're still applying rationalization, and specifically, we're rationalizing our numerator. And by the way, before we even rationalize our numerator, when you plug in 0 into h, you do get 0 over 0, and hence that's why we're applying rationalization to eliminate this indeterminate form. So we take square root of 4 plus h minus 2 over h. You multiply this to the conjugate of your numerator, which is square root of 4 plus h plus 2 over square root of 4 plus h plus 2. And again, this is a minus b times a plus b, so we do have difference of squares, so we can rewrite our numerator based on a squared minus b squared. So let's just write a minus b times a plus b, and this is a squared minus b squared, just so you're following. And hence we're able to rewrite our numerator in terms of a squared minus b squared, so we would have 4 plus h, and this is minus 4 over h times square root of 4 plus h, and this is plus 2. We can simplify our numerator, so we would just have h, because the 4 and negative 4 cancels out, and then we have h in our denominator times square root of 4 plus h, and this is plus 2. And as you can see, we're able to cancel out h, which is also causing you to get an indeterminate form to begin with. So that's why we're left with 1 over square root of 4 plus h, and this is plus 2. And from then on, we're able to evaluate our limit when h approaches 0. So this is 1 over square root of 4 plus h plus 2, applying direct substitution by plugging in 0 into h. We get 1 over square root of 4 plus 0, and this is plus 2. As a result, we do get 1 over 4 as our final answer. Therefore, the limit when h approaches 0 is 1 over 4. So moving to number 4, we see that we have limits when t approaches 0, and we have square root of 9 plus t minus square root of 9 minus t over t. Applying direct substitution by plugging in 0 into t, you see that you do get an indeterminate form 0 over 0. And again, we're still rationalizing our numerator for us to eliminate this indeterminate form. So even if you're seeing two radical expressions in your numerator, it's going to be rationalization. So you have square root of 9 plus t minus square root of 9 minus t over t. You multiply this to the conjugate of your numerator, which is square root of 9 plus t, plus square root of 9 minus t. And this is over square root of 9 plus t, plus square root of 9 minus t. And notice that we still have difference of squares, so we can rewrite our numerator in terms of a squared minus b squared. So I'm just writing this again for you. So we have a minus b times a plus b, which is essentially equal to a squared minus b squared. So we take our numerator, so we have 9 plus t. Make sure your b is in a bracket. So this is minus, then you have 9 minus t. And this is all over t times square root of 9 plus t plus square root of 9 minus t. And we're able to simplify our numerator by distributing the negative sign into each of the terms. So we have 9 plus t minus 9, and this is plus t. We can cancel out 9 minus 9, so we're left with 2t in our numerator, and this is t over square root of 9 plus t plus square root of 9 minus t. So we see that we have 2t in our numerator over t in our denominator times square root of 9 plus t plus square root of 9 minus t. We can cancel out t in both our numerator and our denominator, so we're left with 2 over square root of 9 plus t plus square root of 9 minus t. So now from this point on, we're able to evaluate the limit when t approaches 0 using our simplified expression 2 over square root of 9 plus t plus square root of 9 minus t, because you were able to successfully eliminate t, which is the term that is causing you to get an indeterminate form 0 over 0. Applying direct substitution by plugging in 0 into t, so you have 2 over square root of 9 plus 0 plus square root of 9 minus 0. So you should get 1 over 3 as your final answer. So for question 4, we have limit when t approaches 0. Our limit is 1 over 3. Now moving on to number 5, we see that we have limit when x approaches 3, and this time we do have two radical expressions, and they're actually both found in our numerator and our denominator, as opposed to having them just in our numerator. And for us to eliminate our indeterminate form, and first of all, why do we even have an indeterminate form to begin with? Because if you do apply direct substitution by plugging in 3 into your x, you do get 0 over 0. So in this example, we do have to rationalize twice. So we take our expression square root of 7 minus x minus 2 over square root of 4 minus x minus 1. So we multiply this expression with the conjugate of our numerator and our denominator. So in that case, we would have square root of 7 minus x, and this is plus 2 over square root of 7 minus x plus 2 times square root of 4 minus x, and this is plus 1 over square root of 4 minus x plus 1. So notice how you're not allowed to have square root of 7 minus x plus 2, and if you were thinking, okay, maybe I can just have square root of 4 minus x plus 1 in my denominator, as opposed to having two expressions that are being multiplied to this term, well, don't even think about it, because that's not going to work. So that's why we need to separate our two expressions and rationalize twice. So we would have to rewrite our numerator and our denominator, and because we're seeing difference of squares again, we're able to write this in terms of 7 minus x minus 4, and you multiply this to this term, which I'm going to highlight. So we have square root of 4 minus x plus 1 being multiplied to 7 minus x minus 4. And I'm just going to rewrite this being a squared minus b squared, just so you do have that reference. Now, looking at our denominator, we see that we have a minus b, and we also have a plus b in this case. So again, this is a squared minus b squared, difference of perfect squares. So we can rewrite square root of 4 minus x minus 1 times square root of 4 minus x plus 1 in terms of a squared minus b squared. So this is going to be over 4 minus x minus 1. And don't forget to multiply this to this expression, which will be highlighted in green. So this would be multiplied to square root of 7 minus x, and we have plus 2. So now just by looking at our numerator and our denominator, we're able to simplify some expressions. So I'm looking at this, 7 minus x minus 4. So we would get negative x, and this is plus 3, times square root of 4 minus x plus 1. This is all over negative x plus 3, multiplied to square root of 7 minus x plus 2. And in fact, we're able to eliminate negative x plus 3 in both our numerator and our denominator, so we're left with square root of 4 minus x plus 1 over square root of 7 minus x plus 2. And then we find the limit when x approaches 3. So limit when x approaches 3. So we have our modified expression square root of 4 minus x plus 1 over square root of 7 minus x plus 2. Applying direct substitution by plugging in 3 into x, so we have square root of 4 minus 3 plus 1 over square root of 7 minus 3 plus 2. So we do get 1 over 2 in this example. And hence our limit when x approaches 3 is in fact 1 over 2.